Welcome. I was having a discussion back in January 2021 with a colleague about automation in architecture. And I don't think I did a very good job describing how the skills and expertise of computational design really fit together all these different pieces from the design studio to the site. So I took some time and I made those materials, and that's what I wanted to present today. So a lot of people think of robots when they think of automation, and certainly that's something I really want, a robot that is creative and can build. But I'm also someone that thinks a bit more abstractly about that, and also think algorithmically and computationally, and all the different things that can be automated. And there's also some related technologies that I wanted to bring up. Certainly, building information modeling, where we attach data to geometry, is very much the handle that computational design uses to manipulate all this stuff. And also GIS is a really important technology which connects the studio with the site. So I wanted to start off by saying that we love prefabrication. It's really starting to show that you can reduce your construction time and also raise the quality of materials through prefabrication. But then you sort of have to turn to modularity, which asks what's the optimal way that all these pieces need to fit together. And these solution spaces, these design spaces, are massive, and that's not a really obvious thing. And so you really have to turn to math to start revealing some of these deeper relationships. And immediately our attention is directed towards one solution, the trivial case. All the lengths are equal, all the connections are similar. Certainly there's architects that have made whole careers of always picking the trivial case because it's pure or minimal. So I want us to imagine a really generic average design studio. You can tell it's a design studio here because they have old architectural models scattered around the space. But we're going to make one assumption about the design studio is that they've accepted that buildings are becoming more complex. And a client comes in with a project. Admittedly, this is a bit of a contrived project, but they're trying to renovate a building, and there's a hole in the roof for some reason. They need to fill it, and they want something artful. They want something creative. And so I sort of think of a successful project as sort of this soup that needs to be made by committee. And there's all sorts of different ingredients that need to go in a project to make it successful. Community, sustainability, and we're lucky in this case that the firm thinks that computational design is one of those ingredients that make a successful project. So we're going to follow now two different design options. One is the trivial case in case some value engineering needs to go on. But also a hyper complex design option where every single piece is a different length and all the connections come in at different angles. And initially, even just during the design phase, humans have a distinct weakness when they're trying to tell really similar things apart. But if we sort of adopt the tenets of computational design, or maybe think of this in terms of computational BIM, then we have a really great tool to track all these tiny changes and always be able to keep track of things. So then it's time to talk to a manufacturer, and they look at our proposed design that's really complex in all different parts, and they nearly throw a fit. But as you look at sort of additive and subtractive manufacturing and more robotic manufacturing, really interesting consequences come from the implementation of this technology, in that every single part becomes much more equal cost to produce. And sort of the economies of scale really melt away. Some people have described it from going from mass production to mass customization. We do have a bit of a problem though, because as we finish, we need to get all these pieces with slight differences in an organized way to site. And I really think, I really would encourage to take a page out of Amazon's book, and they don't really place their bins in relation to where humans need to find them in their latest warehouses. They just put the bins wherever and let the robots figure it out. And that's when we come to the site. Again, the GIS technology allows us to know where all these pieces need to go. And through the use of QR codes or RFID tags, it becomes much more trivial to put together these much more complex shapes on site because we know where they need to go. And virtual construction design and all their sophisticated scheduling and spatial information. I also wanted to include all the sort of upcoming information technologies like augmented reality and construction robots. All these things are driving efficiencies on site that really need to be welcomed. By way of wrapping up, I wanted to reiterate that I think all our communities deserve better architecture. And hopefully, I've tried to describe how computational design, competency, and expertise really unifies this whole platform to build better architecture. As always, if you enjoy creativity or like building big things, this is the place for you. Thanks so much.